Hello guys, I'm Miss Y, and today we are back to the Form 5 Chapter 7 Measure of Dispersion for Group Data. In this chapter, we have learned the depletion and the measure of depletion. First, we go into the depletion. Before we learn about the measure of depletion for group data, we need to learn how to construct histogram and frequencies polygon for a set of group data. Example 1. The data on the right show the height to the nearest cm of the group of 5 pupils. A. Determine the class intervals for the data if the number of classes required is 6. Construct a frequency table based on information in A. Hence, complete the frequency table with the lower limit, upper limit, midpoint, lower boundary, and upper boundary. For the A, the largest data is 173 and the smaller data is 145. The number of classes is 6. Then we'll use the formula size of the class interval, largest data value minus smaller data value divided by number of classes. So we take the 173 minus the 145 and divide by 6, and we get the 4.7. So we just into the nearest number 5. Therefore, the class intervals are 145 until 149, 150 until 145, 150 until 154, 155 until 159, 160 until 164, 165 until 169, and the last 170 until 174. For the B, we just create a table, include height, frequency, lower limit, upper limit, midpoint, lower boundary, and upper boundary. For the CM, we just copy it at the A, and the frequency. How we get the frequency? We count in this box how many frequencies have until 145 and 149. So have 2, we get 144 and 148 here, so it's 2. For 150 and 154, 153, 150 and 152, so we get 3. For the lower limit, we just get the class of the first, first in the class is 145, 150, 155, and 160, 165, and 170. For the upper limit, we take the behind of the classes is 149, 154, 159, 164, 169, and 174. For the midpoint, we use the formula lower limit plus upper limit divided by 2. So we use the 145 plus 149 and divide by 2. We get the 147. So this is the midpoint for the 145 to 149. For the next, we use same as the 145 and 149. We take the 100 lower limit plus upper limit. So it's 150 plus 154 divided by 2. So we get the 152. For the lower boundary, we also use the formula upper limit of the class before it plus lower limit of the class. So what is the upper limit of the class before it? It's the 145. Is before the 145 is 144. So we take the 144 plus 145 and divide by 2. So we get the 144.5. For 150 to 154 classes, we take the 149 plus 150 divided by 2 and get the 149.5. For the upper boundary, use the ruler upper limit of the class plus lower limit of the class after it. So we use the 149 plus after the 149 number is 150. So 149 plus 150 and divide by 2 and we will get the 149.5. Next, we take the 154 plus 155 and we get divide by 2 and we get the 154.5. Example 2. Construct a cumulative frequency table from the frequency table below. So we create a table, include the edge, frequency, and cumulative frequency. The edge and frequency we just copy it at the equation, and the cumulative frequency, how we get the cumulative frequency? Because the frequency for the class tag 10 to 19 is the first classes, so we just copy it to the cumulative frequency. So for the next edge classes, we take the cumulative frequency at the next frequency. So it's 4 plus 5 and we will get the 9. For next, we take 9 plus 8 and we get 17. 17 plus 7 and we get 24. And 24 plus 3 we will get 27. Example 3. The frequency table below shows the speed of car in km/h recorded by a speed track camera along a highway in a configuration. Present the data with a histogram and frequency polygon by using a scale of 2 cm to 10 km/h on the horizontal axis and 2 cm to 10 car on the vertical axis. We just create a table. Speed, number of car, midpoint, lower boundary, and upper boundary. For the speed and number of car, we just copy it at the indication. Midpoint, for midpoint, we're using the 70 plus 79 divided by 2, and we get 74.5. Same as down, 80 plus 89 divided by 2, and we get 84.5. For the lower boundary, we take the before the number of 70 is 69 plus 70 divided by 2 and we get the 69.5. 79 plus 80 and we get the 7 divided by 2 and we get the 79.5. For the upper boundary, we are using the 79 plus 80 divided by 2 and we get the 79.5, and 89 plus 90 divided by 2 and we get the 89.5. Okay, this is the histogram for the equation. This is the vertical axis and this is the horizontal axis. For the down is the speed and we use the lower boundary to the right, and here is the number of cars. For 69.5 we get 5 number of cars. 79.5 we get 10, 20, 30, 25 and 10. Next, this is a frequency polygon. At the down, we're also using the lower boundary, but for the frequency polygon, we need to start at the 0 and end at the 0. So we do the cross using the midpoint. So for 59.5 to 69.5, the midpoint is 64.5. So we right here for 69.5, the midpoint is 75, 74.5, 84.5, 94.5, 104.5, 114.5, 140.5, typo, 124.5, and we end the 0. So when we already draw this cross, so we just line it. And this is the frequency polygon. Example 4. The frequency table of the right shows the stored content of 60 types of food. A. Construct an ogive to represent the data. B. From the ogive, determine the first quartile, median, and the third quartile. So we do a table, add frequency, upper boundary, and cumulative frequency. For the upper boundary is 99 plus 100 divided by 2, and we get 99.5. 149 plus 150 divided by 2, so we get the 149.5. For the cumulative frequency, because the edge of class 50 until 99, the frequency is 0, so we just take it to the cumulative frequency 0. So for the edge for 100 to 149, we take the cumulative frequency, add the next frequency, and we get the new cumulative frequency. Set as out, take 4 by 11 plus 11, and we get 50. 50 plus 50 is get 30. 30 plus 21, we get 51. 8 plus 59. 51 plus 8, we get 59. 59 plus 1, and we get 60. So we want to count the first quartile, median, and third quartile. We need to use the formula for this. First, we're going to count the first quartile. So it's 1 per 4 times 16 equal to 15. What is 16? Because our total of frequency is 60. Take the 4 plus 11 plus 15 plus 21 plus 8 plus 1, and we get the total 60. So in the graph, we find the 50 for the cumulative frequency, and we draw a dot line. When we touch the line of the graph, so we're going down. And this is the Q1 for the answer. So from the graph, the final quartile Q1 is 199.5. For the median, we use the formula 1 per 2 times 60, and we get the 30. In the graph, we find the 30. When we touch the line and we going down, and this is Q2. So in the graph, the final quartile Q2 is 249.5. For the third quartile position is 3 per 4 times 60 equal to 45. So in the graph, we find the 45. Draw the dotted line until touch the line in the graph and going down. So this is the Q2. So the answer for final quartile Q3 is 279.5. Next, measure of deviation. After we learn how to construct an ogive for a set of group data, now we are going to learn how to determine range, interquartile range, variance, and standard deviation as a measure to describe depression for group data. Example 1. Park Hamidi had recorded the mass of pineapple that he harvested from his farm. The following frequency table of ogive shows the data that he obtained, determine the range and interquartile range for the data. How we count the range? The range is midpoint of the higher class minus midpoint of the lower classes. So what is the midpoint of the higher class? It's 900 up to 999. So we take the 199 900 plus 999 divided by 2 and minus the midpoint of the lower class is 400 to 499. So 400 plus 499 divided by 2. So we get the 949.5 minus 499.5 and we get the 500 gram. And now we need to count the interquartile range. So for the interquartile range, we need to use Q3 minus Q1. So we count the Q1 first. The Q1 formula is 1 per 4 times total of frequency. Our total frequency is 80. We use 6 plus 12 plus 60 plus 24 plus 14 plus 8 and we get 80. So 1 per 4 times 80 and equal to 20. In the graph, we find the 20 and we touch the graph line, go down. So we get the Q1 is 614.5. For the QT, we take 3 per 4 times 80 equal to 60. So in the graph, we draw a line at the 60, touch the graph of the line and we're going down. So this Q3 is 809.5. So the interquartile range is Q3 minus Q1. So we take 809.5 minus 614.5 and we get 195 gram. 195 G. Variance of standard deviation. For group data can be optioned using the following formula, and this is the formula for variance, standard, and standard deviation. Example 1. The frequency table below shows the values of quartile to the nearest liters used daily by a group of families in a housing area. Calculate the variance and standard deviation of the data. Okay. And create a table variance of water, frequency midpoint, fx, x power 2, fx power 2. For the value and frequency, just copy it in the question. For the midpoint, we take 150 plus 159 divided by 2 and we get the 154.5. 154.4. 160 plus 169 divided by 2, 164 divided by 2 and we get 164.5. For the fx, we take the frequency and times the midpoint. So x times 154.4 is 1236. And next is 12 times 164.5 and we get the 1974. For the x power 2, we take the midpoint and power 2, we will get the answer. And fx power 2, we take the frequency times the x power 2. X times 23x70.25, it will get the 190962. Now we're going to count the sum of frequency, sum of fx and sum of fx power 2. Add the all frequency and we get the 695. Add all the fx and we get the 174175. Add all the fx power 2, we will get the 3215133.75. Now we need to find the mean. This is the mean formula. Sum fx divided by sum f. The sum fx is 17417.5 and the sum frequency is 95. So we take the 1 741.7.5 divided by 95, and we get the 184.34 meters. For the variances, this is the formula for it. Sum fx power 2 divided by sum frequency minus mean power 2. So we take the 3215133.78 divided by 95 minus 1741.5 divided by 95 bracket power 2, and we get the 229.1856. And we just let the decimal into the 2, so it's 229.19. For the standard deviation, this is the formula for standard deviation. Square root sum of fx power 2 divides sum of frequency minus mean power 2. So square root 229.185956. So we get the 115.1389. Let it in the 2 decimal, so it's 15.14. For the box plot, we have learned that a box plot is the method to display a group of numerical data graphically based on the 5-number summary of data. They are the minimum value, first quartile, middle, third quartile, and maximum value, similar to histogram and frequency polygon. For the A is the symmetric distribution, because the Q1 and Q2 and Q3 is at the middle, and the right at the right, left and right is same as the longer. For B1 is the left skew distribution, because the left side is longer than the right side. For the B2 is right skew distribution, because the right is longer than the left side. Example 1. The ogive on the right show the means in G of 19 star fruits. A. Construct a box plot based on the ogive. B. Here's a set of distribution shape of the data. A. From the ogive, we know the minimum value is 18 and the maximum value is 150. For the position of Q1, is use the formula 1 per 4 times total frequency. Our total frequency is 90 equals to 22.5. So the graph 22.5 is a Q1, is 116. For the Q2, 1 per 2 times 60, 1 per 2 times 90 equals to 45. In the graph, find the 45. Cast the graph going down, so it's 123. For the Q3, is 3 per 4 times 19, and we get 67.5. In the graph, we find the 61.5, and we draw a line, touch the graph going down, and we get 128. For the box plot, this is the minimum value, and here is the maximum value. For the box, the first line is Q1, and in the middle is Q2, and the last is Q3. We just draw a box here and line the maximum value to the box and maximum value to the box. So the distribution of the data is skewed to the left because the left side of the box plot is longer than the right side of the box plot. Thank you. That's all.